show IP EIGRP neighbor, show IP INT brief. Your interface E0 by 0 should be configured as 30.1.2, 255.255.255.0. No shut. Show IP INT brief. Show IP INT brief. LAN piece is working fine. AC is still booting. R3 is fine. R4 is acting like a server. Host name, HO, head office, server. Interface E0 by 0. IP address 10.1.1, 255.255.255.0. No shut. IP default gateway 10.1.1. Sorry, the IP address has to be 2. So show IP INT brief. So you have LAN PC, you have server. R5. R5 is branch PC. Interface E0 by 0. IP address 172.16.10.2, 255.255.255.0. No shut. IP default gateway 172.16.10.1. Show IP INT brief. Cisco host name, branch office, server. Interface is 0 by 0. IP address 10.2.2.2. 10.2.2.1. So this ASA is here. R4 is behind him as a LAN PC. R5 is going to act as a server. So 4 and 5 is behind ASA. 1 is in front of ASA. 2 is in front of R1. 3 is, I think, yeah. 3 and 4 is the thing. 5 and 6 is here. Okay. So 1, 2, 5, and 6. This is branch router. That is R2. This is head office router. Let's start. Already I showed you some policies yesterday in the lecture. We saw how the policy is configured on both the side and how to test it. Let's see some netting part also in these two locations. Okay, we'll try to make an overlapping networks between these two sites and see how we can do NAT. Okay, between these two locations. You already know about this deployment mode, that is routed mode and transparent. We already did routed mode and transparent mode. You see the NAT slide, security level. Object group. Good, so it started. Show interface IP brief. This is fine. Show route. Ping 12.1.1 to, but now the topology has changed. So run pipe section EIGRP 12 and 20 on R2. Show run pipe section EIGRP 12 and 172. No, we change this. Now we have no network. We have network 30.1.1.0 0.0.255. So run pipe section. Okay. Let's start this firewall also. I I hope it doesn't crashes. I don't know what's happening. Let's work. I think it will work. Show IPINT brief. This is here fine. Show IPINT brief. This is also fine. Show run router. At least router is pinging. 30.1.1.2 is this router. ASA just now I started, so let's see. What is creating issue? 21 is down. So run. So run router. Show EIGRP neighbor. Let's debug and see what exactly is issue. Received hello from serial 1 by 0. Okay. Received hello from 20.1.1. Sending hello on his. Okay. No problem. So IP route EIGRP 10.30.192 is present. Okay, so it started. Host name ASA2, host name ASA1. Show interface IP brief. Interface E0 30.1.1 255.255.255.0. No shut. Name if outside. Interface E1 IP address 172.16.10.1 255.255.255.0. No shut. Name if inside. Show interface IP brief. Router EIGRP 10. Network 30.1.1.0. Mask. Network 172.16.10.0 255.255.0. Network 10.2.2.0 255.255. Show EIGRP neighbor. Show route ping 20.1.1. Good. And this fellow ping. Yes. 5 and 6 is behind ASA. Show route. Okay. So let's add some policy which is not there. Show access list. Or first we'll try to do NAT. Now see, you have a network of 192.168.10.0. So whenever it goes out, or sorry, we will do static NAT and see how it works. Okay. 10.1.1.2 should be identified as 20.1.1.10. So object network, name of the this thing. Okay, like we are doing static NAT, not dynamic. And now you know static NAT is one-to-one mapping. So just give some name, server, host, private IP, NAT, DMZ to outside, keyword static, public, so excellent. Object, same we do it for here also.
Munawar,
Yeah.
if I can just ask, how did you come up with the 10
Hello, I didn't
for
get.
net? Okay, I was asking, how did you come up with dot 10?
10,
Yep.
this one.
Not 20.1.1.10 to map to
Okay.
net outside.
No, see, basically, when you see the diagram, uh, this is the public pool I'm having. Okay. This is the public IP address it's like available with me. This is, if you see, it is public pool and it is /24, right? So I'm having, say, at present I'm having 254 IP, public IP. So I have decided I'll be giving this public IP which is recognized by internet, which is registered with my name. So I took it 10. I have a pool of public IP. Okay.
Okay. All
So
right.
I took one of the IP, that is 21.1.10. Okay. Same thing. If you see, I'm having a pool of 30 also. 30. So there also I'll be taking 30 network. Okay.
All right. Okay. All right. Understood. Thanks.
Yeah. So host is 10.2.2.2. The term is what? NAT. Always remember you have to give the direction. Same thing what you used to do in the router also. No? Always specify from where the traffic is going to come. That means where is that server located. So server is located in DMZ, and you have to tell your firewall that when to do NAT, that is translation. So this is nothing but like the same command which you normally used to do on router, IPNAT inside and IPNAT outside. So that time we used to go on the interface where the server is lying, and we used to go and say IPNAT inside, and then which direction you want to do NAT, we used to go and say IPNAT outside. So here we are telling my firewall that this is the location where the server is located, that is on DMZ, and you have to NAT when it goes out or when somebody from outside try to enter it. Like, it can be on the both direction, because many times the server also will go on internet to get himself updated. If it is an antivirus server like that, he will go out. So the server is located in DMZ and it will go on internet, that is outside direction. So whenever he goes out, he should never carry the private IP address which is 10.2.2.2 or 10.1.1.2. So when you give this command, actually you are telling your firewall this is the location, and this is how you have to. This is very important in router also. If you forget to give IPNAT inside and IPNAT outside, it's not going to work. And secondly, you have to give the term that this is static, that is 1 to 1. So here also you have a pool of IP address. Out of that, I have taken 30.1.1.10. Always check it, because in static you will come to know, no? Whatever you have done, he will show you. NAT from DMZ. See, he is already writing something. He's telling one in use and one most use. NAT from DMZ to outside. So from DMZ means this fellow is going to come. And when you're sending him outside, you translate it to 30.1.1.10. Same thing you're telling him. When somebody comes from DMZ, suppose your server is not there in DMZ, it is in inside, then you should say inside. Or suppose the name of that interface is something else, private server or public server, whatever name you have given to the interface, the location tells the firewall that this is the guy who is there, and this is the guy. When he goes out, you have to do NAT, because I told you there is a sequence of things which my firewall do. He will check for the existing connections, whether this is an active connection, then he will check for the policy, then he will check, you know, if there is a NAT has to be done. Okay, and everything he goes in sequence. Last time I showed you the slide that how the sequence take place. The Cisco ASA appliance receives the packet and verifies if the packet belongs to the existing session. The Cisco ASA appliance checks the routing table to determine the egress interface of the phone. Cisco appliance check the configured security policy to determine if the packet should be allowed. That is very important. No? NAT comes afterwards. And if NAT is configured, it is applied according to the egress interface chosen. So here I have chosen outside. So according to the egress interface I have chosen, he will do the things. The Cisco appliance record the session and forward the packet from the outside interface. So everything has to be followed. What was there inside? What has to be done for the outside? Which IP address he has to take in public, and then only he will send it on internet. See, IP address is 10.0.1.10, and he has to get translated into 209.165.201 whatever dot 0/24, whatever IP address you have selected. So according to my setup, public IP is 20 and 30. So I'll translate this accordingly. So direction is very important, how you specify. So now actually if you are actually translating, you don't have to specify the, you know, the network also. Okay, so let's see. When I'm creating an access list for out dash in permit TCP, okay, the source has to be like, say, 172.16.10.0. Again, this can be also netted, huh? And the destination will be the object server 1 equal to access group out dash in interface outside. So say when I say object server 1, actually is telling this is for others, like, you know, for us it is actually 10.1.1.2. We are allowing a traffic from 170 to 16.10.0 on definitely on the 10.1.1.2. Actually it is 10.1.1.2. Okay, for administrator this is the actual access list, for others this is the actual. You specified object server 1 and we have to allow like that. So let's see. 20.1.10, show access list. There is a hit count here. Line VTY 04, transport input telnet and SSH, password Cisco. 20.1.110, show CON in detail. Now, in this connection, they will always show you the private IP address, because this is the connection administrator is watching. So accelerate, if you see, people are coming and asking for 20.1.110, it get translated into 20.10.1.1.2. build inbound TCP connection for outside user whose source port is 26 to DMZ, whose actual the person tried was 20111023. One minute. Let me send him out. Line PTY04, password Cisco, transport input telnet and SSH. I'm just trying to send my server out. To see some activity here. See here. I just send my server out on internet. Check how the translation take place. Build outbound TCP connection for some outside router that is 12.1.1.2 for 23 to DMZ 10.112.20252, but actually it get translated to 20.11.2050. So when he sees, see, the router can see somebody who is 20.1.1.10 is getting connected, but actually speaking is 10.1.1.2. The router can see 20.1.1. That means my ASA definitely translating 10.1.1.2 into 20.1.1.10, so that when it launches R2, it is introducing himself as 20.1.1.10, which is the public IP address. Okay, just 1 minute. I'm just coming from washroom. 1 minute. Okay. Any question regarding that? You can try it with this one also. Show accelerate debug NAT 12.1.2. Yeah, R5 is not natted. So when R5 is going, it is R6 who's got natted. So we go here and say 12.1.2. 12.1.12 is R2, and though it is going from high to low, so there is no policy requirement. It's not getting telnet. Let's check what's the issue. Show accelerate. Sorry, logging. Enable logging console 7 logging trap. Show IP int brief. Show run. Show IP route 12.1.2 30.1.10 30.1.10. Now there are two people logged in. One is 30 and one is 20. Just to show you that what IP address they are carrying outside on internet. Now in dynamic, we'll see something like, okay, for LAN users, object network LAN users, you all, will disable the login. LAN users, then the command is network subnet 192.168.10.0 255.255.255.0 NAT. Inside direction again, dynamic let's say interface. Interface means which interface? So it's going to take outside interface IP address. Outside interface IP address is also public IP address because we don't have IP address. So if we don't have IP address, it's going to take outside interface IP address. Show accelerate. Nothing is there. Send them to outside. 192.168.10.2 source port 31284 destination sorry, to outside it was converted to 20111, that is outside interface. Let's check. Okay, just 1 minute. Hello, Islam. Hello. Okay, so when you said interface is going to take, okay, now same thing you can do it on ASA also. Now in this we wanted some policy based NAT, like let check the policy based netting, because you can do with overlapping networks also, like you have the same network on the other side in the branch also. Many times what happen, 1 minute, just let me undebug all. Object network LAN, one more object I'm creating, subnet same 192.168.10.0 255.255.255.0 NAT for inside when they go outside. Now you see there are a lot of options, like first two options are static and dynamic. So static is always designed for servers and dynamic is for LAN users. The term dynamic means like if it is one to many, many to few, many to one, or many to interface. So normally nobody goes for many to many. So there is, people don't have public IPs to waste on users, like they can be natted with a single IP address. Many to one and many to interface is really famous. People go for many to one and many to interface. Many times you have this kind of netting also, where you can specify, like policy, like you can specify that if this is my source and this is my destination, then do this type of translation. If this is my source and this is my, like you have multiple internet, multiple location internet, multiple ISPs, you have taken multiple internet, like redundancy. See, at present you are sending your traffic from your LAN directly to the internet from only one router R1, and that is the only internet you have. Many times you might have multiple internet, like two internet. So initially you want this particular network to be source and destination always. If this is the if you want to send it to a particular ISP, you want that translation to be done with that particular public IP address and send to the that particular ISP, say ISP1. Okay, and same network, if or different subnet or different VLAN in the same LAN want to go on, like for example I will show you. This is your source and this is your ISP, suppose say ISP1. So if you want to send the traffic to ISP1, you want this to be netted with say 20. But suppose you have one more router, say R7, and now this is also connected to ISP2, or there might be same router with two connections. One is S1 by 0, one is S1 by 1. That is also possible. ISP2 is ISP1. So this is your source, and if this is your source, You want the traffic should get netted with this particular network or this particular public IP address getting stuck. And if this is your source, and if this is your next ISP, possible that next ISP might be having some different public IP address, say 40.1. So you want, if this is the subnet, X subnet or Y subnet, you want them to go for ISP1, it should get natted with this IP address. If Y subnet comes in, and if they want to go for ISP2, they should get natted with this ISP. That means there is some kind of policy requirement that ASA has to follow. That means there is some instruction that ASA has to follow. That if this is the source and if this is the destination, then it should get natted with this network. Many times possible that you want to send your LAN to multiple branches via multiple ISPs. So one particular source, but there are multiple destinations. Like possible, if you want to send the traffic to say branch 1, then you will always prefer ISP1, and you should get, these people should get natted with that public IP address, that is 20. And if same network or same source, possible, not, no need to have different source, same source, different destination, then they should go with second ISP. That means they should get natted with second public IP address, that is 40. So one source, two different destination, two different ISPs, and accordingly, so that is kind of a policy net where the ASA is going to follow some policy. Okay, let me just check it because I did it long time. 1 minute, huh? For that we need to create an access list also. Just wait, let me check. Just 1 minute, I'll just check in one folder. Just stop. I stopped my sharing. 1 minute, huh? Hello, 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 hello.